Hello. So hello everyone and very good morning. We will start the session. Okay, let's just start the session, guys. We will in today's session we will be covering few topics of RCC. Good morning everyone. Okay, we will start the session, guys. So in this session we will be covering, this is the fourth lecture, understood? So from now onwards your class timing will be from, for this RCC series, the class timing will be from 11 AM. Understood everyone? 11 AM. So most probably till this Sunday I'll be finishing off this. Okay, this session. Understood everyone? So you can scan this QR code, you can directly join to my Telegram channel, and the PDF of this lecture will be available on this Telegram channel. Understood everyone? Shall we begin? Okay, we will start the session, guys. So today is the first question. Now answer it very carefully. Answer this question very carefully. Now, the permissible. So in the previous lecture we have covered 20 questions. Okay, so I think 22 question. So we'll be starting from 21st question. Okay, so today we will be covering three topics, that is basic of working stress method as well as design for shear, and if we get the time then we will cover the next topic, that is design for doubly reinforced beam. So three chapter we need to cover in today's session. Most probably two we will be covering. Okay, 50 question we will cover in this session. Yes, this is the right answer. Now the permissible bending compressive strength of M25 grade of concrete is, now you can see in the question it is given as sigma CBC is 8.5 Newton per mm square. So sigma CBC is given in the question. Its short term and long term modulus ratio is nearly. So what is the answer? Short term and long term modulus ratio for concrete. Understood everyone? If sigma CBC is given, so long term modular ratio is nothing but modular ratio is defined as Young's modulus of Young's modulus of steel upon Young's modulus of concrete. Yes or no? Okay, so short term, and for long term Young's modulus it is nothing but 280 by 3 sigma CBC. 280 by 3 sigma CBC. Young's modulus of steel is nothing but 2 into 10 ki power 5. Understood? And for EC is, for concrete, 5000 under root of FCK, it is 25. Clear? So this will comes out to be 8 and this will comes out to be 280 upon 280 upon 3 sigma CBC, that is 8.5. You will get the answer. You will get the answer. ठीक है, वो आज आ जाएगा यार, वो मेरे से मिस्टेक हुई होगी कि PDF नहीं शेयर हो पाई होगी, आज आ जाएगा. Okay, what will be the correct answer for this? 11. 11 is the correct answer. 8 and 11. So option A is the correct answer. Understood everyone? Okay, we'll move ahead with the next question. Please answer this. What is the ratio of flexural strength FCR to the characteristic compressive strength of concrete FCK of M25 grade concrete? Good morning everyone. Okay, answer it. Please answer this question. Now, very good. Now, what is the ratio of flexural strength FCR to the characteristic compressive strength of concrete? Now, FCR is nothing but FCR is 0.7 under root of FCK. Okay. Now, the ratio of characteristic compressive in the M25 grade of concrete. So, look very carefully. 0.7 under root of 25 upon the characteristic compressive strength is 25. So, this is nothing but 0.7 into 5 upon 25. So, this is nothing but 0.7 by 5. So, it will be less than 0.7. Okay. It will be less than 0.7. Okay. So, 0.7 divided by 0.5 is 0.14. Option C is the correct answer. Understood everyone? Thank you so much, bhai. Option C is the correct answer. We'll move ahead with the next question. Now answer this question. Minimum spacing between horizontal parallel. This is a good question. This is a very good question. Now remember this. There are two datas. Minimum spacing between horizontal bars as well as the minimum spacing in the vertical reinforcement. Okay, vertical bars. Answer this question. Answer this question. Yes. 24 till 24 we have covered. There are 36 questions in this chapter. So we have reached to 23rd. Okay. So what is the correct answer? Now you can see very carefully. Now look. What is the minimum spacing? Minimum spacing between horizontal parallel reinforcement bar of different diameter should not be less than, you can see very carefully, there are three criteria. Okay, three criteria is diameter of the bar, the minimum spacing is diameter of the bar or diameter of thicker bar. Most probably if the bars are of equal diameter, diameter of bar. If the bar of unequal diameter, diameter of thicker bar. As well as 5 mm more than the nominal size of aggregate. Nominal size of aggregate. 5 mm more than nominal size of aggregate. You can see why this codal provision is given, why there is a minimum spacing, because whenever you pour the concrete, so what will happen, the aggregate does not stuck in between the reinforcement. That is why there should be a clear spacing. Understood everyone? Otherwise, if the spacing is very less, the aggregate in the concrete will get stuck in between this space. That is why this provision is there. So what will be the correct answer? One diameter of thinner bar? No, the correct answer is one diameter of thicker bar. Understood everyone? Now moving ahead with the next question. Now from here you will get the new question. Okay. From here you will get the new question. Now answer it very carefully. What will be the correct answer? If phi is the nominal of reinforcing bar, nominal dia of reinforcing bar, if phi is the nominal dia of reinforcing bar, Fx is the compressive stress in the bar. Okay, compressive stress in the bar. ये कल बताया हुआ अनुराग वर्मा, 4 से 5 सेंटीमीटर साइड फेस, जो हम लोग साइड में जो स्पेसिंग देते हैं, क्लियर है? What will be the correct answer? Now this is a very good question. Here the notations are different. Here the notations are different. Okay, notations are different. Okay, so you can see the phi is the nominal diameter of the bar. If phi is the nominal diameter of the bar, reinforcing bar, Fx is the compressive stress. Fx is the compressive stress. This is nothing but sigma c. Okay, sigma c, compressive stress, and FBD is the design bond stress. FBD is similar to tau BD. Understood everyone? So here the notations are different. Okay, the anchorage length of the straight bar is, the anchorage length is nothing but phi into sigma c. Here phi into Fx upon 4 times of tau BD. Tau BD here is FBD. So what will be the correct answer? So pi, option D is the correct answer. Understood everyone? Just the difference of the notation. Clear everyone? Clear? We'll move ahead with the next question. Answer this question. This is also a very good question. Please answer this. The effect of creep on modular ratio is? Yes, Vignesh. Bond stress. Yes, bond stress increases by 25% in compression, and for high grade of steel it is increases by 60%. Today we will see these concepts also. The effect of creep on modular ratio. Now you can see, if I see the short term modulus, the answer is yes, very good yaar. Shubhendu, very good. Option B is the correct answer. You can see very carefully. For short term static modulus of elasticity, it is nothing but Young's modulus of steel to the Young's modulus of concrete. Okay, for short term it is nothing but 2 into 10 ki power 5, and this is nothing but EC is 5000 under root FCK. Now whenever you see the long term static modulus, whenever you see the modulus ratio for long term, it is nothing but EC. So for EC value it changed by 1 plus theta. Yes or no? 1 plus theta. So this 1 plus theta comes in the numerator. EC ES upon EC, this is nothing but 1 plus theta. So you can see, by considering the long term effect, the modular ratio increases to increase it. Understood? So in the long term the effect of the creep comes out. Okay, whenever the effect of the creep comes out, it increases. It increases, guys. Option B is the correct answer. I hope it is clear. Yes or no? Now moving towards the next question. Please answer this. Now very good. Very good, Arun Kumar. The correct answer is, you can see, in working stress design, if the modular ratio is M, okay, if modular ratio is M, okay, in the question it is given as modular ratio is M and steel ratio is R. Steel ratio is given as R. Okay, the critical neutral axis constant. This constant is given by, very good, this constant is given by M upon m plus r. M upon m plus r. Understood everyone? Clear? So the correct answer is option B. Option B is the correct answer. Very, very good. In the working stress method, you must have designed this formula. K into D. Okay, K into D. So this K value is this. Modular ratio M upon modular ratio M plus R. Now, moving ahead with the next question. Answer this question. This is a very good question. As per IS 456-2000, for a singly reinforced rectangular section, which of the following is correct? XU maximum is limiting value, limiting depth of the neutral axis by D for FE 415. So here three values are there for finding XU limiting or maximum, XU limiting or maximum, or rather XU maximum. Okay, this depends upon the grade of the steel. Okay, for FE for FE 250, FE 415, for FE 500 and FE 550. Okay, XU maximum is given as 415, XU maximum is given as. Now answer it very carefully. Very, very good. Now what is the value for FE 250? What is the value for FE 250? It is 0.53 guys, है ना? 0.53D, 0.53D. And for FE 415 it is 0.48D, 0.48D, 0.46D and 0.44D, 0.44D. So this is how you will find the neutral axis depth for balance section. This is for balance section. Understood everyone? Clear? अभी बताएंगे ये क्वेश्चन भी आएगा. Now answer it. Now XU for FE 415 it is not 0.84. For FE 415 it is 0.48D. Option B. And the depth of the centroid of compression, always it is not 0.43. Depth of the rectangular position of the stress block is 0.38. It is wrong. Option B is the correct answer. Option B is the correct answer. Yes or no? We'll move ahead with the next question. Answer this question guys. Answer this question. In a reinforced concrete beam design, the distance between the centroid of the area of tension reinforcement and maximum compressive fiber is known as. This is a very good question. Please answer it very carefully. Please answer this question very carefully. Please answer this. Look very carefully. Now listen. In reinforced concrete beam design, the distance between the centroid of the area of the tension reinforcement. These are tension reinforcement. Understood? These are tension reinforcement. The distance from the centroid of the tension reinforcement and the maximum compression fiber is this much. And this distance is known as effective depth. This is known as effective depth. Option C is the correct answer. Please don't be confused with lever arm. It is not lever arm. Understood? Shubhendu, it is not lever arm. It is effective depth. Please read the statement very carefully. The distance from, this is not lever arm. Lever arm is CG of the compression stress diagram to the CG of the reinforcement. That is lever arm. Understood everyone? No, it is not lever arm. That is what I'm Shambhu Gupta, it is not lever arm, brother. It is effective depth. Now lever arm is, you can see, if I want to make the lever arm here, see, you can see this is the lever arm. So this is the stress diagram. So here the tension force, the CG of the reinforcement as well as CG of the compression area. This is lever arm. This is lever arm. But in the question you are asked with CG of the tension reinforcement to the topmost compression fiber. That is why it is effective depth. Understood? Okay, move ahead with the next question. This is a very good question. I am pretty sure that you won't find this statement in your note copy. Now look very carefully. For aggressive environment, now aggressive environment means exposure condition as severe. You need to treat the exposure condition as severe. The assessed surface width of crack should not exceed. Now in the concrete, let us suppose this is the surface of the concrete. Okay, what happens is, in the case of the aggressive environment, after the shrinkage there are some cracks developed. So what is the maximum width of the cracks? What is the maximum width of the crack in case of severe environment? This is a very good question. No, the correct answer is no. You can see, in case of aggressive environment, the maximum crack width should not exceed 0.1 mm. 0.1 mm. Please listen to me. The maximum width of the crack in case of severe environment or aggressive environment should not be more than 0.1 mm. And in no case, the width of the crack should exceed 0.3 mm. And in no case the width of this crack should exceed 0.3 mm. So for mild exposure condition, the width of the crack should not exceed 0.3 mm. Understood everyone? But for severe environment condition, it should not exceed 0.1 mm. And whenever the concrete is in contact with aggressive soil, then aggressive soil or aggressive moisture, okay, then it should not exceed 0.2 mm. So you just need to remember these two values, that for severe condition it should not exceed 0.1 mm, and for any case it should not exceed 0.3 mm. Understood everyone? Clear everyone? So answer here is 0.1 mm. 0.1 mm. Okay, we'll move with the next question. Please note it down in your copy. I'm pretty sure that you won't get this data in your copy. Understood? Okay, understood? In no case the width of the crack should exceed 0.3 mm, and for severe exposure condition it should exceed 0.1. Okay, in between mild and severe, okay, it should not exceed 0.2 mm. So this is the logic. Here. Clear? Hindi mein? Just a moment, I'll explain this in Hindi. Just for this question, I'll explain this in Hindi. That देखो, सीवियर कंडीशन में 0.1 से ज्यादा नहीं होना चाहिए, 0.1 से ज्यादा नहीं होना चाहिए, किसी भी केस में 0.3 से ज्यादा नहीं होना चाहिए, ये ध्यान रखिएगा. Again, this is a very good question. Now answer this question. No. Now you can see the factor of safety for steel in working stress method is. Now you need to answer for steel and concrete both. Very good. In working stress method, there is not for limit state method. We are asking for in limit. Very good. Very good. In limit state method. Now this question is for working stress method. The question is for working. Very good, Vignesh. Very good. In LSM limit state method, the factor of safety for concrete, the partial safety or specifically partial safety factor for concrete for concrete is nothing but 1.5 and for steel it is 1.15. But here you are asked with the working stress method. Now see very carefully. In working stress method, you can see, I'll take one of the example. This is a very good question, guys. This is a very good question. Always student used to remember both the value of limit state method, but they forget to remember the value of working stress method. I'll derive you how the value of steel comes out to be 3. And for working stress method, factor of safety for concrete is factor of safety for concrete. It comes out to be 1.8. It comes out to be 1.7 to 1.8. So please do remember these two values, 1.7 to 1.8, and for steel it is 3. Understood everyone? Now how it value comes out to be, you can see if I take the M30 grade of concrete, M30 grade of concrete means FCK is equal to 30. Okay, and as per IS code, we test the concrete in cubes. We test the concrete in cubes, but we cast them in structure. So code says as that you suggest the value of FCK as 0.67% of FCK. On this 0.67 FCK, you apply the factor of safety of 1.5. This comes out to be 0.44 FCK. This comes out to be 0.45 FCK. Understood everyone? Now you can see very carefully 0.67, it comes out to be 0.45 FCK, 0.45 FCK. So you can see very carefully the value of 30 Newton per mm square is reduced to how much? 45% of 30. 45% of 30 will comes out to be roughly around 13.4. So it is nothing but, you can see, this value reaches up to 14. This value reaches up to 14. Yes or no? Yes or no? And for load factor, okay, also you can see, now you can see in working stress method, if let us suppose I have taken M30 grade of concrete, FCK is 30 Newton per mm square. So what are the permissible values? What are the permissible value? If I see sigma CBC, what are the values of M15, M20, M25, M30? So you can see what are the values? 5, 7, 8.5 and 10. You can see 10 Newton per mm square. So you can see very carefully. Look at this value. FCK is 30 and you are permitting 10. You are permitting 10. Yes or no? So you can see that for concrete in working stress method, the value is 30 and you are permitting 10. So what is the factor of safety? Factor of safety is nothing but the yield value is, characteristics value is 30, but you are permitting 10. So factor of safety is roughly around 3 for working stress method in concrete. And how about steel? And about steel, let us suppose we have Fe250. The yield value is 250 Newton per mm square. And how much you are permitting in permissible stress in steel? Sigma ST is nothing but 130 to 140. 130, I'll take 130 Newton per mm square. So what is the factor of safety? Factor of safety is nothing but the yield value is 250, but you are permitting 130 in it. What is the value? What is the value? Okay, if let us suppose you are permitting 140, if you are permitting 140, so you can see this value will comes out to be 1.78. So factor of safety in steel in working stress method is roughly around 1.8 and for concrete it is 3. In question you are asked with steel. So factor of safety for steel. Now for steel it is, no, I'm so sorry, for you are asked with the steel. So if it is steel is asked, you get the value as 1.7 to 1.8. Option A. Option A is the correct answer. Clear everyone? Clear? And for concrete it is B. Understood? We'll move with the next question. Please answer this question very carefully. Now answer this. Working stress method. Now this is a very good question. Working stress method is based on maximum shear stress, linear elastic theory, maximum distortion theory, material failure theory. What is the correct answer? Now in working stress method you can see we are always under elastic limit. We are always under elastic limit. We are always under. So yield value is 250. Yield value is 250 Newton per ms, but you are permitting how much? 130 Newton per mm square. So you can see this value is in elastic range as well as it is linear elastic. It is linear elastic. Understood everyone? So what will be the correct answer? What is the correct answer for this? Okay, linear elastic theory. So working stress method is nothing but linear elastic theory, as well as it is a deterministic approach. It is a deterministic approach, and the limit state method is probabilistic approach. Understood? Now the next question. Next question. Answer this question. According to IS 456, simply supported beam of effective depth D. So effective depth is D for simply supported beam, and the width is effective depth is D and the width of the beam is B. Okay. Shall be so proportioned that the clear distance between the lateral restraint does not exceed. Now the clear distance between lateral restraint shall not exceed. Now answer it for simply supported beam. And answer it for cantilever beam. आगे बनाते हैं, फिगर बनाते हैं इसका. The correct answer here is, you can see, according to IS 456, simply supported beam of effective depth D and width B shall be so proportional that the clear distance between the lateral restraint does not exceed. You can see very carefully. Yes, very good. Very good. For simply supported beam, it should not be more than 60B or 250B square by D. Which one is less? The lesser value, minimum value. And for cantilever beam, from the free end, the lateral restraint, okay, should not be more than 25B or 100B square by D. 100B square by D, the lesser value, minimum value is to be taken. Lesser value is to be taken. Understood? So option here, you are asked with simply supported beam, option A is the correct answer. Understood everyone? Option A is the correct answer. We will move ahead with the next question. Now answer this. This is a simple question. I will not mark the star on this question. It is a very simple question, although I have discussed this. The failure strain in axial and bending compression are respectively taken as the failure strain. When the axial compression, what is the maximum strain in the axial compression? And what is the maximum strain in bending flexure? Bending compression. This value you always remember, 0.0035. Yes, very good. What is the correct answer for 33 question? Yes, this is the correct answer. In bending compression, what is the maximum strain? So when the concrete is treated to be fail, when the strain comes out to be 0.0035, and in the axial compression in the column, what is the maximum strain? 0.002. And for the third value is while casting the concrete, okay, what is the shrinkage strain? If no reinforcement is, minimum reinforcement is given to protect the shrinkage strain. What is the value of shrinkage strain? Please comment in the answer. Please comment. What is the shrinkage strain? जब कंक्रीट को कास्ट करते हैं तो कंक्रीट श्रिंक करता है, इसीलिए दैट इज व्हाई मिनिमम reinforcement is provided. Whenever we cast the concrete, the water from the pore gels evaporate out. Okay, so it gets shrinked, and minimum reinforcement is always provided to resist these stresses. So this value is 0.000003. Understood? Very, very good. Very good. So these three strain you need to remember. So here the answer is 0.002 and 0.0035. Option B is the correct answer. Moving with the next question. Answer this question. As compared to working stress method of design, limit state method takes concrete to, no, very good. As compared to WSM, in LSM, concrete to higher stress level, lower stress level, the stress level sometimes higher but generally lower stress level. Third option is please consider same stress level. Same stress level. Yes, very, very good. In working stress method, now 0.002 is plastic strain and 0.87 Fy upon ES is elastic strain. Whenever we pull a body beyond elastic limit and you remove the load, some of the strain left behind. Clear? Now here you can see in LSM the permissible values, the stresses are in the concrete are higher as compared to WSM. Understood everyone? So what is the correct answer? As compared to working stress method of design, limit state method takes concrete to higher stress level. In LSM, concrete are stress higher as compared to LSM. Understood everyone? So option A is the correct answer. Now answer this value. Answer this question. Answer this question. Now you can see which of the following characterizes the typical failure of over reinforced ratio higher than the balanced ratio. Okay, you need to compare this failure of over reinforced as compared to balanced section. So in over reinforced section, we provide the steel more than the balanced section. Hence neutral axis shift downward. Yes or no? Neutral axis shifts downward. When neutral axis shift downward, what happens is the stresses in concrete, okay, the stresses in concrete reaches to their permissible value earlier than the steel. So here the stress in the steel sigma st upon m. The stress in the steel is less than sigma st upon n, but here the stress in the concrete reaches to the permissible value. Hence, concrete failure is a brittle failure. Understood? So what is the correct answer? The steel does not yield. The concrete crushes and large deflection and tensile crack will be observed prior to failure. The steel yield, the concrete crushes and the beam fails suddenly without warning. Now, please look option B and D. Very carefully, please look option B and D. It is somewhat similar. Now, we'll analyze this. The concrete crushes, okay, and large deflections and tension crack will be observed prior to failure. There will not be any tension crack. Understood? There will not be any tension crack because the stress in the steels are lesser than its permissible value. But yes, the concrete crushes. It is a brittle material. It fails suddenly. It failed suddenly. Understood, everyone? Now moving toward the next question, the last question of the working stress method. Please answer it. The last question of working stress method. The limiting value of depth of neutral axis for concrete beam of overall depth. So the overall depth of the beam is given in the question as 300 mm and grade of the steel is Fe415. Now limiting value of depth of neutral axis for concrete beam of overall depth 300 mm. Okay, effective cover is 50 mm. Effective cover. So capital D is 300 mm. So in order to get effective depth, what we will do? 300 minus normal effective cover is nothing but 50 mm. So the effective depth is 250 mm. So this is given in the question, and also you are given with grade of the steel Fe415. That's it. And from this data you need to find out. No, 144 is not the correct answer. No, Vignesh, this is not the correct answer. You need to apply the formula as XU limiting. So the XU limiting formula, if only the grade of the steel is given is 700 upon D upon, this was the formula that some of the students were asking in the comment section. 700 D upon 0.87 Fy plus 1100. Yes or no? 1100 plus 0.87 Fy. This was the formula you were talking about. So this gives you the maximum depth of the neutral axis. So look very carefully. 700 and what is the effective depth? Effective depth is nothing but 250 upon 1100. 1100 plus 0.87 into Fy. Fy value is nothing but 415. So you'll get the answer in mm. Understood? Here you need to use the. So this will comes out to be roughly around 120 mm. 120 mm, option D is the correct answer. Yes, also you can solve this. Very good. This was the formula. Also you can solve this because it is Fe415. So depth of the neutral axis is nothing but X limiting. Limiting depth of neutral axis can also be taken as 0.48 D. So the effective value depth is 0.48 into D value is nothing but 250. 250. Understood, everyone? Also, yes, this was the mistake. Also you can get the answer from here also 120 mm. So if you remember the formula 0.48 D, it is good. Also you can get the answer from here also. बिल्कुल कर देंगे भाई. आगे बढ़े. We'll move ahead. Now this is the next question, next chapter. Here now in this chapter we will be covering the 35 questions of next chapter, that is shear and anchorage. Shear and anchorage. So now the next chapter, that is shear and anchorage. We will be covering 35 questions of this chapter. I hope you guys are enjoying these sessions. Trust me guys, it takes around 1.5 months to frame such questions such that all the concepts of chapters are covered. Clear? And these are most unique questions which are important for your PSC examinations. Now this is a very good question. In limit state design, permissible bond stress in the case of deformed bar is more than in the plain bar by what percentage? Now, in the limit state design, permissible bond stress, tau BD permissible value, okay, tau BD permissible values for plain bars are given as, for M20, M25, M30, this value you need to remember, M35, M40 and above. So these tau BD permissible values are 1.2, 1.4, okay, and then we have 1.5, 1.7, and then we have value as 1.9. So these are for plain bars, tau BD permissible value. But if the bars are of higher grade, okay, more bond strength will be there. Okay, so you need to increase the permissible values by how much percent? By 60%. By 60%. Understood everyone? Yes or no? For deformed bars, these permissible values are increased by 60%. As well as if the bars are in compression, these values are increased by 25%. But so here you are asked only by the deformed bar. Option D is the correct answer. Clear? 1.2, 1.4, 1.5, 1.7 and 1.9. This you need to remember. Understood everyone? Now moving ahead with the next question. Answer this question according to IS. Now please be careful. There are two IS code, that is IS 456. IS 456, I have given you the explanation that if the length of the member is more than 45 mm, you need to provide one or more than one expansion joint. Okay, more than one expansion joint, one or more than one expansion joints are provided. One or more than one expansion joints are provided. Yes or no? So it is for IS 456, but here you are asked with IS 3414. This is the code for expansion joint. So please put a star mark on this. This is also a very good question. (45 meter). No, please listen very carefully. In IS 456, it is given that if the length of the member is more than 45 meter, one or more than one expansion joint is provided. Okay, but in IS 3414, this value is reduced to 30 meters. So this code suggests that if the length of the member is more than 30 meter, provide one or more than one expansion joint. So this 45 meter reduced to 30 meter if the code is IS 3414. Please listen to it very carefully. Please note down this value. This is IS code specifically for joints. Understood? Written everyone? Shall we move ahead? So this is a very good question. We'll move ahead with the next question. Answer this question. A ready-mix concrete supplier supplied 101 cubic meter of concrete. This is also a very good question. Most probably you'll get this question in your examination. If let us suppose I am the supplier of the concrete and I have supplied 101 cubic meter of concrete to your site. Okay, 101. Specifically I have taken 101. 101 cubic meter of concrete for a slab. As for the minimum sampling frequency, the number of cube sample required are. This is a very good question. A practical question. Now you can see if the concreting is in the range of 1 to 5 meter cube, 6 to 15 meter cube, 16 to 30 meter cube, 31 to 50 meter cube. Number of samples are 1, 2, 3, 4. Now above 50, now listen to me very carefully. Above 50, that is above 51. What you will do, 4 plus 1 sample for additional 50 meter cube, for additional 50 meter cube. Now if it is in the range of 51 to 100, how much you need to add? 40 plus how much is this? 50 is nothing but 51 to 100, 4 plus 1, that is 5. For 101 to 150, that is nothing but 4 plus how much is more than 50? 2 times, so it is 2, that is 6. So your answer will be 6. Option D is the correct answer. Option D is the correct answer. Vignesh, it is not 5, it is 6. Because 4 plus for additional 50 means 51 to 100, it is plus 1. For 101 to 150, in 4 you need to add 2. No. For now please, 4 plus 1 sample for additional 50 meter cube. 1 for additional 50 meter cube is yes, for 101 cubic meter. 101 cubic meter. Yes, option D is the correct answer. If it would have been 100 cubic meter, then the sample will be 5. Then the sample will be 5. Understood? So option D is the correct answer because it is 101 cubic meter. Understood? This is the logic. This is a very good question. Please note down this question, the data. Please note down these datas. Very good question, guys. Shall we move ahead? Okay, after the RCC, I'll take up the survey also. Okay, now please move ahead. Please move ahead. Answer this question. Just a moment, I'll be back in 1 minute. Okay. Just a moment, I'll be back in just 1 minute. I need to bring my water bottle. Just a minute. Now, what is the correct answer for this? What is the correct answer for this? We have seen this value, okay? As per IS 456, the minimum cement content for the respective durability class can be reduced by R kg per cubic meter while changing the maximum size of aggregate from, now if you have changed the maximum size of aggregate from 20 mm to 40 mm, you will decrease the, you can decrease the cement content by how much? By 30 kg per meter cube, by 30 kg per meter cube. Yes or no? But if you have reduced the aggregate size from 20 mm to 10 mm, what will you do? Okay, if you have increased the size from, decrease the size from 20 mm to 10 mm, this R value is plus 40 kg per meter cube. This is an important codal provision. Here the correct answer is option D. Here the correct answer is option D. Okay, we will move towards the next question. Now answer this question. Lap splicers shall not be used without additional precaution beyond the bar of. This is a very good question. I am pretty sure that you will commit a mistake. I am 90% sure that you will commit the mistake. Very good, very good, because in most of the textbook it is written as 36 mm. See, earlier it was 36 mm. The bars greater than 36 mm diameter are not lapped, either they are welded. Understood everyone? But as per amendment, there is amendment in 2007. After that amendment, it is written that the bars if more than 32 mm diameter are not spliced, either they are welded. Okay, so now the correct answer is 32 mm. Earlier it was 36 mm, now it is 32 mm. Understood everyone? Yes, very good, Vignesh. Yes, this is the correct answer. Option C is the correct answer. Very good, very good. I was expecting that you will give the answer as 36 mm, because in most of the textbook you will find that the bars more than 36 mm shall not be, okay, they are welded. Very good, those. Now it is after amendment, it is 32 mm. Clear? Very good. Now we'll move towards the next question. Answer this question. Very good. The correct answer is option A. Option A is the correct answer. For vertical stirrups, the maximum spacing of shear reinforcement. Now look very carefully. For vertical stirrups, okay, so the distance between the vertical stirrups are, you can see this is the main reinforcement, these are shear stirrup, these are vertical stirrups. So near the support, the shear force is more, hence the spacing is less. But as you progress towards the center, the spacing is more. But here also near the support, the spacing is less. Okay. Now for vertical strip, the maximum spacing of shear reinforcement measured along the axis of the member shall not exceed. So the maximum spacing is, let us suppose spacing between the stirrups are SV. So the maximum spacing is okay, SV maximum. So the maximum spacing between them is, if the vertical stirrups are there, okay, we assume that the length of the crack is, so the length of the crack is D. At least there should be one stirrup in between the length of the crack. So what is the maximum spacing? If let us suppose these are the vertical stirrup, it is 0.7 D, 0.75 D, 0.75 D, and shall not be maximum of 300 mm. Understood everyone? 300 mm or 300 mm. So here the correct answer is option A is the correct answer. Option A. If it would have been the bent, if inclined inclined stirrup bars, if it would have been the inclined, for inclined it is 300, it is D. Okay, for inclined it is D. Clear? Now moving towards the next question. Answer this question. In a rectangular beam of section B into D subjected to ultimate torsional moment TU, equivalent ultimate shear can be given as, equivalent ultimate shear can be given as, in a rectangular beam, okay, in a rectangular beam of section B into D. Now the section is B into D, it is a rectangular beam subjected to torsional moment. So there is a torsional moment of TU. So we don't give the reinforcement for torsional, except what we do is we take the additional reinforcement for shear and bending moment. So equivalent ultimate shear can be given as, so this is the factored shear force plus 1.6 time of the torsion divided by B. So what is the correct answer? This is the equivalent shear force, V equivalent. So we will give the reinforcement for this equivalent shear which is coming. So what will be the correct answer? The correct answer is VU plus 1.6 TU by B. VU plus 1.6 TU by B. So this is the correct answer. Option A is the correct answer. Understood everyone? Very good Vignesh, very good Vaisak, very good. Now we'll move towards the next question. Look. The percentage of steel as per IS recommendation in compression should not exceed. Now it is a question of beam that the compression reinforcement should not be more than by how much percent of the total cross section area. Maximum compression and maximum tension reinforcement are how much percent of the total cross section area or gross area? Maximum compression reinforcement as well as maximum tension reinforcement shall not be more than 4% of gross cross section area, B into capital D. B into capital D. Hence the correct answer is option D is the correct answer. Okay, option D is the correct answer. Clear everyone? We'll move towards the next question. Answer this. The permissible value of local bond stress for M15. Okay, M15. The ratio is 1 ratio cement and 2 ratio sand and 4 ratio aggregate. है ना? 1:2:4. Cement concrete is permissible value of local bond stress. Yes, minimum value is AST upon BD 0.85 upon, yes. Just now we have seen these value. Just now we have seen this value. What are the values for permissible bond stress? So now you can see for M20 tau BD permissible was 1.5. Okay, for M25, for M30, M35 and M40 and above. M40 and above. Yes or no? For M40 and above. Clear? So the value is 1. No. 5 is not the correct answer. I'll give you the answer. Please don't worry. 1.2, 1.4, 1.5. This value is 1.2, 1.2, 1.4, 1.5 and then 1.7 and 1.9. So for M15, this value is, for M15, this value is 1 Newton per mm. 1 Newton per mm square. So you need to convert this in kg per centimeter square. Your task is to convert this into convert this for M15. You are asked with M15. Okay, you are asked with M15. So the permissible value is 1 Newton per mm square. Convert this into kg per centimeter square. And take the value of G as 10. You'll get the answer. Now look, 1 Newton per mm square. 1 mm has how many centimeter? 10 power minus 1. So there are 2, 10 power minus 2. So in order to convert Newton into kg, what will you do? 10 power minus 1. So you can see 10 power minus 1 is left. So this is 10 kg per centimeter square. So 10 kg per centimeter square is option B. Option B is the correct answer. Understood everyone? I hope it is clear. Because most of the students will remember these value 1.2, 1.4, 1.5, 1.71. So in the question it was asked for M15. M15 value is 10 kg, and also we have converted them into kg per centimeter square. Understood everyone? Moving ahead with the next question. Answer this question. The shear strength can be ensured in a beam by providing. How will you ensure the shear strength in the beam? By providing binding wire on main wire, high strength deformed bar, rounded aggregate as well as stirrups. Now what is the correct answer? By which method you will strengthen the beam in shear? Now it is provided by, yes, very good, it is provided by stirrups. Okay, in beams stirrups are provided. In beams stirrups are provided. Understood everyone? So to strengthen the beam in shear. Clear everyone? So they take the shear. Understood? Now moving ahead with the next question. Now this is a good question. This is a good question. What is the distribution of shear in a rectangular beam? In a concrete rectangular beam. Now you can see. If you have remembered the value, this is nothing but. Now the shear distribution, if you need to plot the shear distribution, you can see. So above the neutral axis, there is a concrete section, so it is parabolic. Below the neutral axis, only steel will be taken. So steel will be taken. This is nothing but rectangular. This is rectangular. So you can see parabolic over and below the neutral axis, wrong. In a reinforced concrete, if it is a reinforced concrete beam, so the answer will be parabolic over neutral axis and rectangular below neutral axis. Rectangular over neutral axis. Option B is the correct answer. Understood everyone? Option B is the correct answer. This is the shear distribution. Okay, this is the shear stress distribution along the cross section. Along the cross section. Understood everyone? This is along the cross section. Next question. Answer this question, guys. For bar in compression, the values of bond stress for M20 grade shall be increased by. Now, if it is in compression, we have just discussed it. For the bars in compression, the tau BD values, the tau BD permissible values are increased by 25% as compared to bars in tension. As compared to bars in tension. Yes or no? What will be the correct answer? What will be the correct answer? And for deformed bar, it is increased by 60%. Yes or no? Yes, option B is the correct answer. This is a simple question. Now moving ahead. Answer this question. Answer this question, guys. What will be the correct answer? The longitudinal shearing stress acting on the surface between the steel and the concrete are called the longitudinal shear stress. Now you can see, because of the unbalanced moment, okay, there is a unbalanced bending, unbalanced direct force remains in the beam. Because of that there is a, if this is a reinforcing bar and there is a concrete around it, so there is a unbalanced, so because of that unbalanced force, there is a shear which is developed on the surface of the concrete. So that is known as bond stress. Yes, very good. This is known as bond stress. The longitudinal shearing stress acting on the surface between the steel and the concrete are known as bond stress. Option A is the correct answer. Understood everyone? Okay. It's my humble request, if it is possible for you, to please share the session, okay, amongst your friend. Okay, there are so many Telegram channels, and also there are so many WhatsApp group of your college friends. Please share if possible, okay, because I have given 1.5 months to frame these questions. So whenever someone put such an effort, and I'm taking this session on YouTube, so please share these session among your friends so that they get benefited from these session. Okay, and these are really good questions. You must have seen, this is the 4th class. Almost till now we have covered 100 questions, 100 to 120 questions we have covered till now. Okay, so you must have seen that I have not copied question from any book or any previous year. I have framed these questions in order to see that are very important for your upcoming examination. Understood everyone? So I am giving my 100%. I am on time. Okay, I am giving my 100%. A typed form of questions are there in front of you so that it looks good on the smart board. Okay, I am giving my time. So it's my humble request to please share the session amongst your friend. Okay, chale, moving ahead. Right, answer this question. If nominal shear stress tau V exceeds if there is a nominal shear stress is tau V, exceeds the design shear strength of concrete. So if this tau V exceeds the design shear strength of concrete, the nominal shear reinforcement IS 456 shall be provided for a shear stress equal to. Again a very good question. Now you can see what is the correct answer. Very good. Now you can see the shear which is acting on the beam is, if nominal shear stress exceeds the shear strength of the concrete. So the shear reinforcement will be provided for tau V minus tau C. Tau V minus tau C. For this shear, the shear reinforcement will be provided. So there are 4 codal provision here. If the shear which is coming on the beam is less than tau C by 2, no shear reinforcement is provided. No shear reinforcement is provided. Understood everyone? Now if the shear which is coming on the beam is more than tau C by 2, but it is less than tau C. So you need to provide the minimum shear reinforcement. Understood everyone? So you need to provide the minimum shear reinforcement. But if this tau V is greater than tau C but less than tau C max, okay, so shear reinforcements are provided. Okay, shear reinforcements are provided for which value? Tau V minus tau C. And if the tau V value which is coming on the beam is more than tau C max, this section is redesigned. So these are the 4 codal provisions that you need to remember. Understood? So here the correct answer is option C. We'll move towards the next question. Again a very good question. Please put a star mark on this. What is the correct answer? Lap length including anchorage value of hook of bar in flexural tension shall be lap length including anchorage. You need to increase the anchorage value of hook of bar in flexural tension. So whenever the bar is in flexural tension, what is the very good. The correct answer is LD or, yes, very good Vignesh. The correct answer is C. It is LD or 30, which is more, whichever is more. So development length LD or 30 times of the diameter of the bar, whichever is more. This is the answer. Option D is C is the correct answer. C is the correct answer. Understood everyone? Moving towards the next question. Answer is a rectangular beam of width 200 mm and depth 300 mm is subjected to shear force of 200 kilonewton. The maximum shear stress produced in the beam is a very good question. Very, very good question. Direct tension is 2 LD. Yes, very good, Vignesh. 2 LD or 30 mm. And what is the straight length of the lap? 15D or 200 mm. Yes or no? Straight length of the lap is 15D or 15 phi or 200 mm, whichever is more. Clear? So 3 values are there. Now a rectangular beam. So you can see the width of the beam is 200 mm. And how about the depth of the beam? Depth of the beam is given as 300 mm. Shear force is nothing but this factored. This is factored shear force of 200 kilonewton. 200 kilonewton. The maximum shear stress. Shear stress is the maximum shear stress. You need to find the answer. And it is a rectangular beam. It is a rectangular beam. This is a very good question. Please answer it very carefully. Yes. Now the average shear stress is, we know that the average shear stress is nothing but the V upon B into D. V upon B into D. So you can see very carefully 200. For kilonewton we convert this into Newton by multiplying by 1000 upon 200 into 300. So you can see this is nothing but 1000 by 100. 1000 upon 100. Clear? So this is 1000 upon 100 Newton per mm square, and we know that the maximum shear stress is nothing but, in rectangular section the maximum shear stress is 3 by 2 of tau average. 3 by 2 of tau average. This will be completed as 3 by 2 of 1000 divided by 300. So this is 100. So this is 5 Newton per mm square. So without calculator you will get the answer as option C. Yes. Understood? So this is, now if this is a rectangular section, the value is 3 by 2. Can you answer me for no, we will move ahead with the next question. Answer this. Answer this question. The bond between steel and concrete is mainly due to the bond between steel and concrete. So there is a bond that the concrete will hold the steel reinforcement. Why? It is due to adhesive resistance, frictional resistance, mechanical resistance, and all of the above. This is a simple question. By logic you can apply the answer. No. Here the correct answer is all of the above. By logic you can apply the answer. Yes or no? Yes. The bond between steel and concrete is mainly due to adhesive resistance. Yes, it is due to adhesive resistance, as well as for frictional resistance. There are some factors, mechanical resistance also. Understood? So all of the above is the correct answer. All of the above is the correct answer. So concrete holds the reinforcement. There is a bond between steel and concrete because of the adhesion, friction, mechanical purpose. All of the above is the correct answer. Now moving ahead with the next question. Answer this. The maximum shear stress for M20 grade of concrete is. Now here you can see the maximum shear stress for M20 grade of concrete. So you are asked with the tau C maximum value. Now for tau C maximum value for M20 grade of concrete. Now you can see this value 2.8, 3.5. This value is in LSM. So just remember the value of LSM, tau C maximum. So grade is M20. Okay, M20 or rather M15. M15, M20, M25, M30, M35, M40 and above. M40 and above. Yes or no? So these values in LSM values are LSM value for tau C max, and for WSM the value for tau C max. Both have different values, 2.5, 2.8, 3.1. Okay. So the yes, very good Vignesh. The value is 2.5, 2.8, 3.1, 2.5, 2.8, 3.1. So here the value is 3.4, 3.1, 3.5, 3.7, 3.5, 4. So these are the values for LSM. These values you need to remember: 1.6, 1.8, 1.9, 1.6, 1.8, 1.9. So you can see you are asked with M20. So 2.8 and 1. There is no option 1.8. Hence you will go for 2.8. 2.8 is the correct answer. 2.2, 2.3, 2.5, 2.2, 2.3. Option A is the correct answer. Clear everyone? Clear? Moving ahead with the next question. This is a simple question. This is a very simple question. Answer it. Spacing of shear stirrup in RC rectangular beam. Now the shear stirrup spacing is, now you can see in the beam, okay, in a simply supported beam. I give you the example of simply supported beam. Okay, the shear force diagram is, if it is a point load or it is a UDL, if it is a simply supported beam subjected to UDL, the shear force diagram is nothing but, the shear force diagram is shear force diagram is, yes, very good. This is a very simple question. Okay, you can see the maximum shear is at the support, hence the spacing is less, and at the center if the shear force is less, so spacing can be more. So as you move towards from the support towards the center, spacing decreases, spacing increases. So spacing of the shear strip in RC rectangular beam is kept constant. No, it is not kept constant. Decreased towards the center of the beam, increased. So decrease is not increased. Okay, increased towards the center of the span. So correct answer is option. No. Look, no. Increase at the end. I'm so sorry. Decrease towards the center. No, it increased. Increase at the ends. No, it is not increased. Decreased. So increase towards the center of the span. Option D is the correct answer. Yes, option D is the correct answer. Now moving ahead with the next question. Answer this. The shear strength of concrete depends upon the shear strength of concrete depends upon which values? Okay, the grade of concrete, percentage of longitudinal tensile reinforcement, shear reinforcement provided, all of the above. The shear strength of concrete. Now look, this is shear strength of concrete. Tau C maximum value depend not. The shear strength of concrete depends upon the grade of the concrete. Yes, it depends upon the grade of concrete, as well as it depends upon the percentage longitudinal reinforcement, as well as shear reinforcement provided. Hence the correct answer is option D. Hence the correct answer is option D. So shear strength of concrete depends upon all the factors which is given in the question. Now if in the question it was asked as maximum shear strength of concrete, it depends on maximum shear strength of concrete, that is tau C maximum value. It depends upon grade of concrete only. So here maximum term is not there. That is why option D is the correct answer. Understood everyone? Vaisak, understood? Understood? Yes or no? Option D is the correct answer. Clear everyone? If it would have been the maximum shear strength of concrete. Now in the previous question only we have seen the value of maximum value of the shear strength of the concrete. It depends only on the grade of the concrete. But if it is the shear strength of concrete, that is only tau c value. It depends upon the grade of the concrete as well as longitudinal reinforcement as well as shear reinforcement. Hence option D is the correct answer. Clear? Moving ahead with the next question. This is a simple question. I will not mark star mark on this. It is a very simple question. The development length of the bar. So LD length is development length of the bar as per IS 453 given by. So you can see 4. Now this is nothing but 5 into times of the permissible stress upon sigma s upon 4 times of tau BD. 4 times of tau BD permissible bond stress. Tau BD is permissible bond stress. So what is the correct answer? What is the correct answer? So stress in the bar is sigma s, 4 times of tau BD, okay, permissible bond stress. So what is the correct answer? Option B is the correct answer. Option B is the correct answer. Understood everyone? Shall we move ahead? No. Next question. If diameter of reinforcement bar is D, anchorage value of the hook alone will be. For hook alone will be. What is the very? Now it is for hook. Hook have 180-degree bend. Hook is 180-degree bend. So you can see 180-degree. For 180-degree it is. Now we have seen for 90-degree, okay, for 45, 90, 135, and it is. What will be the correct answer for hook? If diameter of the reinforcement bar is D, if D is the diameter, anchorage value of the hook alone will be. What will be the anchorage value? Yes, very good. For hook it will be 16D or 16.5, okay, or 16.5. Yes. Option D is the correct answer. Moving towards the next question. Please answer it very carefully. Again a codal provision. What will be the correct answer? Here two options are correct. Please remove this value. Please do not consider this value. Now answer it, because option A and C was similar. Option A and C was similar. Now the minimum shear reinforcement formula, this is given in. Now you can see to avoid sudden collapse just after a shear crack, minimum shear reinforcement is provided in pre-stressed concrete in the form of stirrup. So as per IS 1343. Now remember this minimum shear stirrup formula was given in IS 1343, okay, 1980. So this is the IS code, IS 1343, IS 1343 1980. So this is clause number 24, 1343 1980. Okay, so minimum shear formula is nothing but ASV is the area of the shear stirrup into B times of the spacing of the shear stirrup is equals to 0.4 times of 0.87 Fy. 0.87 Fy. So you can remember this 0.87 Fy into ASV should be more than how much? 0.4 times of the B into SV. This line you need to remember. 0.87 Fy into SV is equals to 0.4 B into SV. Understood? Okay, so option C is the correct answer. Clear everyone? Option B is the correct answer. So this much is the minimum shear reinforcement you should provide. Okay. Yes. Even it is for pre-stress concrete. Okay. Understood everyone? Moving towards the next question. Shear failure at section of beam without shear reinforcement normally occur on plane inclined at an angle to the horizontal. Now you can see that how the failure of the beam takes place. Okay, so how the failure of the beam takes place, shear failure takes place. So this crack will develop like this. This crack will develop like this. So it is at an angle of 45 degree. It is at an angle of 45 degree. Understood everyone? So the correct answer is option B, to the horizontal. Understood? 45 degree to the horizontal. Okay, you can derive this by taking the stress diagrams. Okay, from SOM you can derive, from the concepts of strength of material you can derive the concepts. Understood everyone? Clear everyone? No, the correct answer is 45 degree. It is diagonal shear failure. Okay, 45 degree diagonal shear failure. Next. This is a very good question. Please put a star mark on this. If a bar is cranked at both the ends at an angle of 30 degree, the extra length required when compared to the straight bar is D, center to center distance between the top and the bottom steel. What will be the correct answer? Okay, please put a star mark on this. I'll, in the next lecture, please put a star mark on this. Okay. Please put a star mark on this. Okay. In the next class, I'll derive this expression. Okay. Answer this. If the bar is cranked at both the ends at an angle of 30 degree. So this you have cranked. Okay. For one side, we will analyze. This is cranked at a length of 30 degree. This distance is D. This distance is D. Okay. So here the correct, this you need to remember, but if you do not remember, it's okay. Don't worry. So you can see very carefully. This is 30 degree. So see, sine 30 degree is, so you'll get this value. Sine 30 degree is D upon hypotenuse. Okay, so this hypotenuse value is D upon sine 30 degree. Okay, and how about this base value? This base value will be tan 30 degree. Tan 30 degree equals to perpendicular by base, D by B. So this base will be equal to D by tan 30 degree. D by tan 30 degree. Just remember these two value. Okay, so H is nothing but this value is 2D. This value is 2D. So how about this value? This value is tan 30 degree is, okay, this value is nothing but 1.73D. This value is 1.73D. This you need to remember. So this value is 1.73D. If the bar is not cranked, the length was 1.73D, but now the length is 2D. How much extra you have given? 2D minus 1.73D. Yes or no? 0.27D. So this is nothing but 0.27D. Now the crank is given on both the side. If the crank is given on both the side, 0.27 into 2 times of D. So this will be equal to 0.27 into 2 times of D is option B. Understood? Clear everyone? Clear? Understood everyone? So how much extra you have given? You have given 0.27D extra length by giving the crank bars. Understood? Shall we move towards the next question? Okay. So last question for today's class. Answer this. Now in the question, a rectangular beam of size, the width is nothing but 230 mm and the depth is nothing but 350 mm. It is effective, it is given in the question. The factored shear force acting at a section is 80 kilonewton. So this is the factored shear force which is acting at a section. If the permissible shear stress in concrete is tau c value is 0.25. So how much is the concrete can resist the shear, which is nothing but 0.25 into 230 into 350. So this cross section can resist the shear of this value. The design shear force is nearly. So the design shear force is nearly, you can see. So in 80, you subtract this value. So this value comes out to be Newton per mm square. So in order to convert this in kilonewton, multiplied by 10 power minus 3. Okay. 0.25 into 10 power minus 3 to 230 into 350. This value will comes out to be, you can see, and from 80 subtract this value, so 0.25 into 230 into 350 into 10 power minus 3. So you'll get the answer in kilonewton. This is your answer. So this is roughly around 230, 350. This will be roughly around 20 kilonewton. Option D is the correct answer. Option D is the correct answer. Understood everyone? So guys, last seven question. Do you want to continue the last 7 question or you want the 7 question tomorrow? Answer in the comment. There are 7 questions which is left in this chapter. You want this 7 chapter now to finish off this chapter, or you want these 7 questions tomorrow? We are about to finish this chapter. There are last 7 questions which is left. Answer this. Answer this question. As per IS 456-2000, for the design of reinforced concrete beam, the maximum allowable shear stress tau c max depends upon. Just now I have told you that the maximum shear stress depends only on grade of concrete and grade of steel. Grade of steel only, grade of concrete and percentage of reinforcement, grade of concrete. This is a very good question and simple question. Tau c max value depends upon, it depends only on grade of concrete. It depends, tau c maximum value depends only on grade of concrete. Yes or no? Grade of concrete. It depends only on grade of concrete. Option D is the correct answer. Yes. Moving ahead. Answer this question. A column of size 450 has unsupported length of 300 and is braced again sideways in both directions. The minimum eccentricities with respect to major and minor principal. This is the question of column. Okay. This I'll again explain you. But this is a simple question. About what it is, eccentricity about major axis. Eccentricity about major axis. L upon 500 plus D upon 30. Answer this. Minimum eccentricities L upon 500 plus D upon 30. Yes or no? Plus D upon 30. So what is the unsupported length? This is 3 meter. So here the D is the bigger value. The bigger value is 600. Yes or no? Yes or no? So eccentricity about the major axis is nothing but, length is nothing but 3000 mm. 3000 divided by 500 plus what is the D? That is 600 divided by 300. So this is 2 and this is 6. So this is nothing but 6 or 2. 3000 upon, what will be the correct answer? 26. Yes or no? 26. Okay, so 26 mm is the correct answer. So only option A or D. So for what about the minor axis? Eccentricity about the minor axis will be equal to L upon 500 plus B upon 300. Okay, so your answer will be, so here the answer will be upon 30. I'm so sorry, this is D by 30. 3000 divided by 500 plus this is nothing but 450 divided by 30. 15 6 21. So your answer will be 26 and 21. Option B is the correct answer. Understood everyone? Next question. Answer this question. A simply supported beam having 200 mm width and 450 mm depth supports a total uniformly distributed load of this much Newton. The nominal shear stress will be, so nominal shear stress is nothing but VU upon BD. You will get the answer. This is a very good question. So this is nothing but 200 kilonewton. This is nothing but 200. This is 200 kilonewton. Answer this question. This is a good question. Answer this question, guys. Yes. This is 200 mm width and depth is 450 mm. Okay. So you can see very carefully. Effective depth supports a total uniformly, UDL is 200 kilonewton. The nominal shear stress. So first of all, we'll find out the shear force. So shear force will be half of the load. Yes or no? Half of the load is nothing but 100 kilonewton. Half of the load is 100 kilonewton. So what is the nominal shear stress? V upon BD. V upon BD. So this 100 kilonewton, this is B in D is 200 into 450. 200 into 450. So convert this into kilonewton, you'll get the answer. Okay. So 100 into kilonewton will be equal to, Newton will be equal to 1000. So this is your answer. So from here you'll get the answer as 1.1 Newton per mm square. 1.1 Newton per mm square. Option B is the correct answer. Yes or no? I guess option B will be the correct answer. Yes or no? Yes. Next question. It is a simple question. Answer it. This is a very simple question. At limit state of collapse in shear, please remember, in shear, limit state of collapse in shear, in case of web shear, it is assumed that concrete cracks when the maximum principal tensile stress exceeds the value of Ft equal to, so the stress, now you can see, look, here you can see, this is a symmetrical beam. Look, this is a symmetrical beam, yes or no? If it is a symmetrical beam, okay, and it is UDL of how much? The UDL, the distributed load, the uniformly distributed load, it is equals to 200 kilonewton. 200 kilonewton. So this is the total load which is distributed equally. This is the total load which is distributed equally. So how much will be the support reactions? How much will be the support reaction? Will be half of it, that is 100 kilonewton here, 100 kilonewton here. Understood everyone? So what is the maximum shear force which is at the support, which is equals to this reaction only? Yes or no? You are confused with WL by 2. Now in UDL what happens is, you must have studied this. Now look, for UDL you must have studied this. This is the shear distribution. Yes or no? Okay, so this is WL by 2 and reaction here is also WL by 2. Yes or no? When this intensity is given as W kilonewton per meter. When this intensity is given as W kilonewton per meter. But here in the question, this total concentrated load is given as 200 kilonewton. So the half of the reaction 100 kilonewton here, 100 kilonewton here. Yes or no? So half this total value is, so here the total value is given as 100 kilonewton. Here the total value is given as 100 kilonewton. So what is the maximum shear force? It is at the support which is equal to 100 kilonewton. So instead of giving the UDL intensity, he have given you the 200 kilonewton load. This is the given. So this total load, it is not intensity, this total load is distributed along the beam. Yes or no? So that was the confusion. That was the trick of that question. So this 100 kilonewton is to be remembered. Yes or no? So if you need to convert this into UDL intensity, how will you convert this into UDL intensity? 200 kilonewton for how much length of the beam? So since length of the beam is not given. Understood? Length of the beam is not given. So directly he have given you the constant, this load. Understood? Now answer this question. Yes. Now please remember that at limit state of collapse in shear, in case of web shear crack, that the concrete cracks when the maximum principal tensile stress, whenever it exceeds maximum principal tensile stress, whenever it exceeds 0.24 under root of FCK, there is a crack in the concrete. Understood everyone? Because the principal tensile stress is more than this permissible values, and concrete is weak in tension. Yes or no? Hence the correct value is option A. Please put a star mark on this value. Next question. Next question. Answer this question, guys. In the design of reinforced concrete beam, the requirement of bond is not getting satisfied. The economical option of satisfy the requirement of bond is by, now let us suppose if there is a less bond strength, okay, and you need to increase the bond strength. How will you increase the bond strength? I give you the hint. There is a football. There is a football, and you converted this football into 4 tennis ball. Okay, into 4 smaller ball. So you can see, so the logic behind is this surface area is this much, this green one. Now the surface area have increased. Now the surface area have increased. So smaller the diameter, more is the surface area. If more is the surface area, more is the contact of the concrete and the steel. Hence, more will be the bond strength. Yes or no? More will be the bond strength. So if it is not satisfied, you will provide the smaller diameter bar more in number. Option B is the correct answer. Yes or no? Option B is the correct answer. Moving ahead with the next question. Again a very good question. Please answer it. A codal based question. So area of the shear stirrup. Minimum shear reinforcement in the form of stirrup shall be provided such that total cross section area of the stirrup, SV is spacing along the length of the member, width of the beam, and F the characteristic strength of steel. Characteristic strength of steel is Fy. So we know that 0.87 Fy into ASV, this area of the stirrup should be more than 40% of 0.4 times of B into SV. This is the condition. So this area of the stirrup should be more than this. So lesser equal to, so the correct answer is option A. Correct answer is option A. Yes or no? Moving ahead with the next question. Again a good question. Please answer it very carefully. Answer it very carefully. As per IS 456-2000 standard, the average permissible bond stress for plain bars in M25 grade of concrete is? Average permissible bond stress. Now please look very carefully. It is 0.8. No. Now look, this is tau BD, average permissible. Now this is average permissible bond stress. Okay, average permissible. This is not maximum value. Average permissible bond stress. M15, M20, M25, M30, okay, and so on. So what is these values? What is these values? So for M15 it is 0.6, okay, 0.6 and then 0.8, then 0.9, then 1. You can see for M25, so this for M25 this value is 0.9. For M25 this value is 0.9. Understood? I hope it is clear. Yes or no? I hope it is clear now. Yes or no, guys? Please note down. Yes, this is the average permissible values. Okay. Now it is clear. So the correct answer is 0.9. Last two question. So answer it. Flexure, shear, bond, deflection. Answer. Now deflection can be controlled by span by depth ratio. Bond. Okay, flexure. So longitudinal reinforcements are given for flexure, stirrups are given for shear, and anchorage values is for bond. So D1. So which option for D1 and A2? Option D is the correct answer. Option D is the correct answer. Understood everyone? Option D is the correct answer. Clear? Moving away towards the next question. This is a simple question. Last two question. Okay. So this is the simple question. We have covered this question. The anchorage value for standard U-type hook as per IS shall be how many times the diameter of the bar? So the anchorage value for hook is 16 times of diameter of the bar. For this is option B. Option B. Okay. Last question for today's class. Answer it. This is also simple question. Just now we have seen this value. Okay. Last question for today's class. The spacing of the nominal shear reinforcement. Now we have seen the formula as 0.87 Fy into ASV should be greater than equal to 0.4 times of B into SV. This SV is spacing. This can be written as 0.87 Fy into ASV upon 0.4 into B. 0.4 into B. So which option is correct? Which option is correct? Option A is the correct answer. I hope it is clear. So this is it for the concepts of shear and anchorage. I have almost covered all the concepts such that all the concepts of this chapter will be covered. Yes or no, guys? I hope you have enjoyed the class. For RRB JE, no, the time is less. I mean, for this mains portion, it is very difficult to take the physics and chemistry. Rather, Vignesh, I'll share you for physics and chemistry, I'll do one thing, that I'll share you the PPT. Okay, I'll try to take physics and chemistry. Because, you know, managing the time is little difficult. Okay. I'll try to finish up the physics and chemistry. Don't worry. Okay. I hope you have enjoyed the session. Please like the session. Okay. Now in the next lecture, we'll be covering the singly and doubly reinforced beam, as well as we'll be covering the concepts of, now in today's class, we have almost covered 60 questions. Okay. We have covered 60 questions. Okay. Now in next lecture, we'll try to cover we'll try to take the session for 2 hours and we'll try to cover 2 chapters, that is singly and doubly reinforced beam, as well as for slab also. Okay. So thank you so much, guys, and please share this session. Okay, these are very good questions. Okay, you only solve such questions, the whole RCC will be covered. Okay, thank you so much, guys, and we'll meet you in the next class. Thank you so much, everyone. Bye bye.